Okay, that took longer than I expected. I was trying to get the YouTube stream working. I don't know why it didn't, but welcome back. We are back. Yesterday we started looking at the model for what we're going to parse these games into. How's everybody's Monday going? I'm still using my mouse instead of using Vim keys, so that's a thing. Last night I started to write some Java docs. So, let's see. And I'm also just trying to get used to moving. But again, this is just Vim stuff. We're learning. So we can go back with B, we can go forward with W, J is down, K is up, L is this way, H is this way. But you'll probably see me use my mouse a lot in the early days because this is only really day 2 of using Vim. So yesterday after stream I did a little bit of starting to document things because we want nice Java docs when we're going through things. But the first thing I kind of realized right away is that we're going to have multiple different types of chess games that are all kind of going to have to send back these tags and moves assuming that they're available, because we want everything that we parse to kind of come back to this idea of portable game notation. Or I guess that's what it is now. I'd like to make something a layer above this, so portable game notation is only one of the possible things that I can be. So I think we kind of need an upper level thing that's going to be like the chess game. So that's kind of where we're going to start right now. We're going to make an interface called chess game. And what we're going to do here is we're kind of just going to make it similar to this portable game notation, except it's going to have like this interface is going to have a get metadata and a get moves. I think is probably where we're going to leave it, is just get metadata, get moves, and then this implementation is going to have more than this. So let's try get metadata, or get game metadata, and that's a map, so we're going to need to import that. And we also need one for moves. So that one right now is a list. Again, this stuff is going to change as we get going. Hey, Tursquill. Get moves. We are trying to build something that can parse chess games really fast today. It's a project that I've kind of been bugging around in my head for a while. And I think this year I want to do a thing where like I kind of get better at a skill, or like just kind of like practice something. No, I don't usually stream this early. I have this week off and I want to try to do something productive in the morning when I'm not working so that I don't kind of waste the rest of my day. Just kind of like wanting to do things or planning how I'll do them later. So I'm going to try to do like an hour of something productive or something that I like in the morning and see how that goes. So we got this interface now for get moves and get game metadata. So that means this is going to implement that. We're also using a ton of stuff here that I just don't normally use. Is this gonna give me a way to just import these? Yeah, add on implemented methods. So like I'm using VS Code here. I don't usually use VS Code for Java. I think I already have a get moves. Did that? Yeah, get moves now needs an override. And you can move up. The cool thing about this new editor that I'm using, this is why I'm kind of using it. It's called Vim, and it's really old, and a lot of people like it, and a lot of people hate it. And funny enough, the reason people like it is the same reason that people hate it. I know I'm kind of looking over here, but I have to sometimes. So the way Vim works is with these things called motions. So like when I'm navigating here, I'm pushing J to go down, K to go up, H to go left, and L to go right. And you'll also notice that like my cursor's on line 102, line 101, but there's also all these numbers around it. That's so that I can jump to things. So like right now what I can do is I can tell that the bracket that I want to select right now is 5 lines down from line 102. So I can type in 5DD. So that deletes it, but it also does something else. But let's undo that. Did I go too far? No, that's right. 102 down to... What doesn't this bracket? Okay, no, it's fine. Yeah. So we'll do that again here. We're going to delete that. I don't know why. We're going to go down. What is going on when I do that? It should be taking that bracket too, I think. Let's go up one and try. Okay, we'll just do this for now. We're still learning, and that's okay. But now I can bring this up to where I want, and I can click paste or not. Maybe VI doesn't work, or maybe the VS Code version doesn't actually work that way. In the real version of Vim, hey Estolia, in the real version of Vim, when you delete something, it goes into your paste buffer, so you can paste it later. But we'll try yank then. We'll do 5. So you can also, if you want to see the commands I'm doing, I haven't got a good setup for this yet, but down here, oh, I'm covering it completely. Underneath me, the reason people hate it is because you don't have to take your hands off the keyboard. If I was using it properly, hold on. Don't let what I've done right now taint you on it. Let me sell it first. Let me sell you on it first. Hold on. So let's switch over to the terminal view here. It's something that can be done completely in terminal. So let's go into that file that we were just in, which was that interface. Or no, it wasn't the interface. This is going to die because I haven't set it up yet. This is why I'm using VS Code. I haven't had time to set up what's called the LSP. But let's move down here. So this is actual NeoVim. So now we're going to take our 5 lines here. So 5DD, X, and now we're going to go up. And above here, we are going to... Oh, interesting. Oh, right, because that's the last thing in the paste buffer. Okay. We're going to keep on doing here. I now understand. So, now we're going to yank, come up here. Yeah, it's all about learning these things. There we go. That's a paste. I don't know why it's not taking that last curly bracket. That's the thing that was really screwing me up. But now we can go into insert mode, and we can just come down here and then throw that there. And then : W to save, : Q to get out, It's like you can easily jump around things. So what I'm trying to learn right now is it's called the movements of Vim. And once you know how to, why don't you like this? Oh, because I already took it, right. So now let's just delete these. We know 5e and x. What? And this is why it's going to take me a long time to get this done. Is because I have to learn all of these key bindings as well. Okay. So yesterday I was trying to do some documentation for my code so that I can remember what I'm working on. And if we ever need to get this game metadata, we're going to have to do a conversion here. Because really, I don't think we want to mix these up. I think we want to keep them separate. Because these are the ones that are from the actual specification, which is something that we looked at yesterday. So this is the actual documented specification for a PGN file. And a PGN file can contain one or many chess games. So while we were looking at that yesterday, we learned that there are standard tags, which are the ones that are defined in the actual standard, but the standard says to be loose and that there may be more or potentially 0 of them. So we also made this spot here for custom tags, the ones that we may support that don't actually exist in the standard. So I think when we get down here, we're going to want to merge those two together, because in this interface here, this get game metadata, it doesn't know that it's actually a PGN file. It just knows that it's a chess game. But over here, we actually have that knowledge of, yes, I am a PGN file, and this is standard and this is non-standard. So we're kind of mixing those two ideas together. So what we're going to do here is we are going to make a new map, which is a string, and we are going to call it game metadata. Or, you know what? Maybe we will make... No, this should be fine. We're not going to be using the game metadata a whole bunch, I don't think. Is there... You know what, though? I don't know. We're going for speed. That's why I don't know. Because I don't really want to be casting all the time. But okay, we're going to go with this for now because we have to make a decision and we're not going to get stuck in analysis paralysis right now. So we're just going to keep going and we'll come back to this if we have to later. So we make this hash map. What don't you like? Oh, wait, new. Right, we got to use our keyword. So we got this hash map. We're going to say for its entry or map.key. Can't remember, or map.entry. Map.entry. That's what it is. Map.entry. Standard tag string. Forgetting my syntax here. E4. This is going to be the standard tags dot entry set. So what this does is we're saying what we're going to do here is we're going to take this. So I guess I understand that some people maybe aren't super heavy into development, and that's fine. So these things are called maps. You're able to look things up. The first thing is the key, and the second thing is the value. So anytime I want to look something up in this map, I need to give it something called a standard tag, and it will produce a string. I've also got another one where I give it a string, and it gives me another string. So an example of this is these tags that we're talking about. If we look at a little bit of PGN data here, In this case here, the key would be event and the value would be Pittsburgh OP. So what I need to do is down here, I've got these standard tags. These are the ones that are going to be defined in the specification. I need to convert, and luckily I've got the string data for them because that's how I made this enum. So what we're going to do here is we're going to loop through this entire map and we're going to convert these to strings and add them to this new hash map. Does this need to be, yeah, add import for hash map. So now what we're going to do is we're going to say game metadata dot put e.key dot get tag name and then e.value. And what this is going to do for us is this is going to slowly but surely fill up this game metadata, and then we are also going to do a game metadata, or no, we want game metadata, whoop, my bad, dot put all, and then we are going to do custom tags. Oops, if I could spell we would do that. Okay, and then after that we are going to return game metadata. So what this does is anytime you want the game metadata, it's going to merge that together again. Because this is all about efficiency and quickness, we're probably going to come back and rewrite this, but that's okay. So now we're left with this model, and I swear we're going to jump back here in a second and talk about why we're doing this, and we're going to talk about how we got here. But this is what we started yesterday, so I just kind of wanted to finish that. So we've got this chess game. A chess game at its very most core has metadata and has moves. The PGN, which is portable game notation, is one way that we can represent these. What we're building, though, is going to handle more things eventually, I believe. But for now, we're just going to stick with PGN because that's an easy format that's ubiquitous. It's what chess.com, Lichess, all the big chess websites use. And then we'll worry about other formats like chess-based database and skid database, and there's other file formats as well. We'll worry about those later. Specifically for portable game notation, though, we've got this idea of, let me hover over this for a second, these tag pairs. So I've actually linked these in my actual Java docs in 8.1 and section 9 of the PGN spec. It talks about what standard tags are, and anything we do with custom tags, we're going to look and reference to section 8.1 of the PGN spec to say, how are we going to format these custom tags? There are rules, especially for export. On import, the custom tags are less of a big deal, but on export, we got to make sure that we're rigid with complying with that. And then the moves are actually stored by ply. So what that means is like one turn consists of 2 moves. So if we come back to this game metadata, white plays e4, black plays e5, and our move list, e4 is 1 move, e5 is the next move. So we're storing them 1 ply at a time. It likely won't stay a list forever because we're going to have more information that we're going to add there. But that is okay. So I think that I'll do documentation offline for now. But this should be enough to have our PGN and our chess game. So I think we're done with that for now. So the way I started the stream yesterday was we're going to do a little bit of recap because now we're actually ready to work on some of this. I had made 2 different importers that were importing that were importing PGNs in a different way. One of them was doing it by doing line reads, which is like in the file, read 1 line as a string, and then when I get that string, I'm going to start manipulating that string, and I'm just kind of going to start moving along like that. And then I had another one that did it using a byte array, which is looking at individual bytes. What I learned was that way is not exponentially, it's a lot faster. It is a lot faster to parse it as a byte than to parse it as a string. So we are going to try to write a new importer. We're going to keep this one around for now because we want reference to it, because I don't want to start entirely from scratch. But we want to write something that outperforms what we already have. And I know that we can do it because we haven't even turned up, like, we haven't really put any pressure on trying to optimize the crap out of it yet. I just kind of doodled for a couple hours and came up with one thing that was faster than another thing. But what we're trying to get to is something kind of like this, where we're going to do a pre-read. So I'm going to back up a little bit. What we just made, that portable game notation, that's going to be something called a deserialization, which means the PGN is a serialized chess game. It is a file that contains a chess game, but it is not a chess game. So you follow so far. The data in that file represents a chess game. We're going to read that chess file and turn it into what our system calls a chess game. So first we're going to do a pre-read, and we're going to look for the start and end of each chess game. And when we find it, we're going to we're going to save the indices of the start and the end location of every game on just a quick read, top to bottom of the file. Where is the start and end? Okay. Once we have that giant list of start and ends, we're going to then attempt to start deserializing, which is taking that file and making an object out of it in a multi-threaded way. So there's two aspects to this. The first part is just parsing the file, and then the second part is actually going to be managing the threads. So right now we're over here in this pre-read phase. So I think the way we're going to do this is, we got our models. Okay. I think we're just going to rename these for now. Just draft import game. Yeah, refactor, that's fine. And we're going to do the same thing with this one. Let it refactor. Okay. So now we're going to make a new class here, and we are going to call it PGN importer. PGN importer. Okay. And this is where, save that. Save that. And we will save this. And we're going to shove this over here. There. Okay. Cool. So, I think I want to zoom out a little bit here. Hold on, I just want to see where my ruler actually... Okay, so we actually can't see a lot. That's okay. We're not going to go that far for right now. This works for right now. Let's get rid of this too. So, there we go. Now we've got a nice big editing space. So this is just our reference. This is what we're actually working off of. So, let's take a look at how we did this last time. So, actually, I guess maybe to start... Let's actually start off the right way here, and we're going to also make an interface here. We're going to call it game importer. Okay, and in game importer, we're going to have... Oop, geez, what am I doing? We're going to send back a chess game. And we're going to call it import games. Okay. Oh, did we make... Yeah, we did make those protected. That's kind of important. These are going to have to go back to public for a little bit. We're not ready for this yet. But the idea is that not anything can create a game, only importers can create games. But we're not really ready for that yet. So we're going to swap those over. This is the way my mind works. Get over it. We jump around a lot. We don't know where we're going. We don't know what we're doing. We haven't really sat down to kind of plan this out, so it's just kind of a feel it out kind of experiment. So PGN importer. Oh, what's this? That's fine. Just reminding me that I'm on vacation. So this is going to be public chess game import games. Oh wait, yeah. Jeez. Hold on. This is gonna have to be a list of chess games. So we're gonna forget about this for now because we have other problems to solve. Do you get to play your Switch too much? I haven't been, just because I haven't gotten Donkey Kong Bonanza, and for the most part there's not a ton of games out, but I played the crap out of Mario Kart, and if I had people who were playing it, I probably would. But the only reason I haven't is because we don't have a ton of games for it. So let's start with we'll start with just a method here that brings back a list of portable game notations, and we'll say import PGN. Mario Kart is really fun. It is super fun for sure. We're going to start with return null so that we can get rid of that error. Okay. So, which is kind of what we did here. We started off with get game. Now we've got import PGN. And we did this with a file input stream last time. So there's two ways we can kind of handle this. We can either handle this with input streams or readers. Readers do a lot of decoding, and they take your byte and they turn it into a character, which, I mean, kind of sounds good. It sounds like something we'd want, but that takes time, right? Every time we do something like that, it takes extra time. At the moment, this solution over here, as crappy as it is, this can, if it's just flat read, so if we look at the code, we actually don't do anything when we're done. We make these strings, we don't do anything with them. What it does is if we go back to that PGN data, it extracts this, so event, and then it extracts Pittsburgh OP, it extracts this E4, it extracts this E5, it extracts this Queen F7 check. It extracts all those little pieces, just looking one byte at a time to try to figure out where the bounds of these things are, but that's all it does. It creates a string here, but it does nothing with it. Same with down here. It creates these strings, but it does nothing. Oh, hold on. Yeah, we don't actually do anything with it. Sorry about that. We don't actually do anything with it. But that's okay. All we're testing here is we just want to see how fast we can do it. when we did it with strings, I could process 250,000 chess games about. I don't have the exact number, but it's around 250,000. It's a 180 megabyte file of just text. I could do it using strings in about 1.9 seconds, which sounds fast. But this one here, with the bytes, I can do it in 0.9 seconds, 0.9 seconds. So it's a whole second faster on average to do it this way. Which again doesn't sound like much, but we're going to be processing millions of games. And there's more that we have to do after we read them. So it's got to be snappy, it's got to be fast. So taking the time to turn these into characters when we don't care about it is a waste of time, is a waste of effort. That said, this is going to slowly get more and more complicated as we move through the PGN spec. There's more things for us to ignore, there's more things for us to care about. In the beginning though, we're going to have to start with some assumptions. To start, I think we're going to assume that every game has at least one of these. Theoretically, you can have 0 tags, but we're not going to start with an edge case. We're going to start because we can refactor, we can change it. So we're going to start with the assumption that every game starts with a tag, or is an empty file. If the file is empty, that's okay. But if there is data in the file, we're going to assume that every game in the file has at least one metadata tag and has at least one move. Theoretically, there doesn't have to, I don't believe you need a move either, because there's a terminator that means game in progress, which is just a star instead of a 1-0, but every game has a terminator. So if we assume that every game has an opener, every game has one move, and it is a rule that they have to have a terminator. If we work on those 3 assumptions, I'm going to move this one over here. If we work on those assumptions alone, that'll give us a good basis to start making something that's quick, and then we can start slowly adding, okay, well now here's the situation where I don't have a tag, now here's the situation where I don't have this. So yeah, we're going to send back a list of portable game notation. So I guess let's start. We don't want to hold it. Okay. I'm trying to think ahead because I know this is going to be multi-threaded, but that's okay. Let's not think ahead yet. Let's just get this working, and then we can figure out how we're actually going to store things and where we're going to keep things. For now, let's just keep it right here. So we're going to give ourselves a list of portable game notation that we're going to call games, and we will say PGN importer. And this will be good because now we can concatenate things. Like if you give multiple files, we can do the reads and concatenate them all together. That'll be a bit rough, but we'll figure that out. Games equals new array list. So now we've got this array list. And as we move through here, we're going to start with a pre-read, and then we are going to go off on an adventure. So do I have access to vectors? Hold on. Why is my bookmark bar always show? There we go. I need to find Java vector. It's the other thing we're going to be doing a lot of. We're going to be doing a lot of, except all, we're going to be doing a lot of research as well. So let's see, what do we got for what is a vector here? A vector implements growable array of objects. Like an array, it contains components. Okay. That's not really what I thought a vector was going to be. What I really want is like a pair or a tuple. But they don't exist here. Because it's really just start and end. It's bounds. Wait, constructs an empty array within a specified capacity. Hold on, let's look at that constructor. That doesn't give me a bound though. Okay, what else do we have at our disposal? Let me bring up another thing here. It's like a pair or a tuple in Java. Do we have anything? We don't have anything native. We're not going to bring in okay. We'll make a class for it. That's fine. We're not gonna bring in a dependency just to handle pairs. We'll just make a pair. That's fine. So inside this game importer, we also need something called what are we gonna call it? Let's call it a pair. We might use it in other places. Or we'll just do game bounds. Game bound. Okay. Public game bound. Int game start. Int game end. Okay. So what we're doing here is we're just setting this up so that these can't be changed later. They're constant so that... Oh, we don't want to set them here, though. We want to set them in the constructor. That's silly. I'm saying that they're not going to change, and then all of a sudden I'm allowing them to. So we're going to say this dot game start equals game start, and game end equals game end. We're going to do get start of game. Yep. Return game start. Get end of game. Return game end. Okay. So now, import PGN, we are going to do a pre-read first. So for now, we'll save it up here. Again, we can come back and refactor this as much as we want. Game bound. Game. Indices. Indices equal new array list. Okay, so now we are going to say determine game indices. Indices, and again, we may come back and change this. That's fine. First, we're just trying to get it to work. So this is where we're going to do a pre-read, and we're gonna have to figure out what is a reasonable amount to read at a time. To read in one loop iteration of a 4 GB file. So let's assume we've got a giant file. Let's say let's read 256 kilobytes at a time. So 256 is a nice number because it's sorry, I'm just thinking. If you do binary, 256 is 1 with a bunch of zeros. It divides nicely into the 2 to the power of stuff. So it's also small. It's less than half a megabyte. It's a quarter of a megabyte. So that means to read the file we have today, which is 178. That means we're only going to have to do the loop less than 700 times, less than 1,000 to get through it. Let's start there. Let's start at 256. So for that, we are going to make a byte buffer that does that. So byte byte buffer. We're gonna make a final int our kilobyte multiplier is 1024 because that's how many bytes are in a kilobyte. And then we're going to come down here and we're going to say 256 times our KB mult. We can actually rename this to multiplier, and that should be multiplicative here. So now we've got the right size buffer. 106 kilobyte buffer. So now that we've got that, we're going to follow what we did here. I haven't done much of this byte array reading stuff, so this one took me a little while to do, and I did it off stream. So right now we've got the number of bytes read, which is going to be important. So we are going to have int bytes read equals 0. So it starts at 0. And we're going to change the way that we do the profiling a little bit. So next we're gonna have to, I think this is where the path is gonna have to come in. So that's where we're gonna get the file that we're actually importing. And this is good because it forces us to do one file at a time, so we're not gonna like go to IO hell. Although I suppose we could multi-thread it, but I don't think we want to yet. Right, so now we need to do our input stream. So we want a buffered input stream, I think. So buffered input stream is new. Buffered input stream, and from here we get a new file input stream, and we are going to pass it path. Okay. I have got to, okay, does home do it? Home kind of does it. Oh, we don't, there we go, that helps. For now we'll just throw. We don't care right now. So for now we'll just throw things when they happen, and we'll come back and we'll do some error handling later, but a file not found exception seems like a pretty good reason not to continue here. And I think we can just pass the same buffered input stream down. So here we're going to say we need, is a buffered input stream an input stream? Extends filtered input stream. Once wrapped in the underline, should not be used directly nor wrapped in. Okay, so we're going to keep this as a buffered input stream. Buffered input stream. Because I don't want to, oh yeah, we're going to have to throw here. No, we can just pass, okay. There we go. So we're going to use the same one. We're just going to read it over it again. So we'll pass that down into here. And now we're doing our pre-read. So we want to read in our buffer's worth in one go. And we're going to have to keep track of how many things we're reading. So bytes read. We need total bytes read, and we need buffer let's say buffer size, I guess, is what this would be. Bytes in buffer, we could go with that. Bytes in buffer. So now we get while bytes in buffer equals in, no, buffered input stream dot read buffer right, and then not equal -1, which means if we're not at the end, okay, what is this is an IO exception. So again, for now we will just throw those. We will do proper error handling later, but for now we're just trying to get this working. So every single time we go through this, we're gonna have to, okay, so now we've got a buffer. And now we have to loop through that buffer. So we are going to do a for loop over the buffer. Yeah, I don't have any macros for any of this yet. Bytes in buffer I plus. So every time we go through this, we're going to add one. And also at the end of the loop, we are going to have to add one to total bytes read. At the end. So these start at 0, this one starts at 0, when this one increments, this one increments. So these stay together, which is good. And now we're going to, this is where we're going to start needing some booleans. So let's say boolean game start found is false. And for now, we'll just say, again, we may not need these. We will find out. We're just kind of screwing around here, seeing what we can get. So now we say if buffer I equals one of these, and we've not found game start, then we are going to say, oh, yeah, we're gonna have to, we don't want to keep declaring that, so let's say, so game start found. I need int game start index equals 0. Int game end index equals 0. And now we're going to, so if I find one of those and the game has not been found, we are going to say game start index equals the total number of bytes read, because that's where it is in the file. And then we are going to set game start found to true. And then now we are going to change this around a little bit. Oops, I forgot I'm in VI. So let's delete the word. Oh, where's my command? Okay. DW, no. Let's try 2DW. Yeah, okay. There we go. And now we can do, no? Okay. Oh, right. Do DW, go back to the start, paste, insert, and so yeah, we are, oops, we're still learning Vim. We're getting screwed over every time we try to do a thing. That's okay. Okay, flip those around so that we don't have to check the buffer thing every time. And okay. Now, this is where it's going to get fun and we can do a little bit of look ahead. We've got these at the end is what we need to look for next. So we've already found this. Everything basically everything else, we don't want to do anything unless we can find one of these. So this is the Terminator. I don't know. I think we're going to have to read ahead. But this is where it gets kind of tricky because, like, the way the buffer works is that I could get to here and then that's the end of the buffer. Which is fine, but, like, I can't always be looking ahead. So I think I'm gonna have to it's interesting because we don't want to waste any movements, right? As soon as we detect this once, all of a sudden we're just never going to do this compare again. We're just always going to look at game start, which is going to be true. And it's only not going to be true when we find game end. So that means this is going to have to be, if I make this as a separate if statement, it's probably going to get triggered right after. And so let's try, we'll try this for now. We'll try an else if for now here, but we're going to do it this way. If game start found. So what are we going to look for first? So we need to know that the game was found. Actually, I guess we know that to be true. We know that to be true, so we don't have to check it. So we can say is our byte. I feel like we have to first find. Yeah. So we're going to have to figure out that we're in the move section first. So I'm just trying to think of how I want to do this, because I don't want to check for too many things, but I need to find this at the end. So I don't want to grab it when I'm in a result. So I guess now I want to find maybe the last one of these. Anyway, I just lost my train of thought. Okay, I'm done. I'll do this later.